So if you remember in the project section in the last previous videos, we have created a AMI of a web server. So what we did, we launched a instance, Windows instance. We installed IIS on that, have run a sysprep, and we created an image of that server. So that particular image, that particular private AMI was used to launch instances in auto scaling group. So that this is the same concept, the golden image concept that we have implemented earlier. So you can customize an Amazon EC2 instance then save its configuration by creating an Amazon machine image. You can launch as many instances from the AMI as you need, and they will all include those customizations that you have made. Each time you want to challenge your configuration, you will need to create a new golden image. So you will need to have a versioning convention to manage your golden images over time. We recommend that you use a script to bootstrap the EC2 instances that you use to create your AMIs. This will give you a flexible way to test and modify those images through time. Alternatively, if you have an existing on-premises virtualized environment, you can use VM import export from AWS to convert a variety of virtualization formats to an AMI. You can also find and use pre-baked shared AMIs provided either by AWS or third parties in the AWS Community AMI catalog or the AWS Marketplace. While golden images are most commonly used when launching new EC2 instances, they can also be applied to resources like Amazon RDS databases or Amazon EBS volumes. For example, when launching a new test environment, you might want to pre-populate its database by instantiating it from a specific Amazon RDS snapshot instead of importing from the data from a lengthy SQL script. There's something called containers. Another option popular with developers is Docker, an open source technology that allows you to build and deploy distributed applications inside software containers. So Docker allows you to package a piece of software in a Docker image, which is a standardized unit for software development, containing everything the software needs to run the code, runtime system tools, system libraries, etc. So AWS Elastic Beanstalk and the Amazon EC2 Container Service supports Docker and enable you to deploy and manage multiple Docker containers across a cluster of Amazon EC2 instances. Now there comes a hybrid approach. So that means it is possible to use a combination of the two approaches, where some parts of the configurations are captured in a golden image while others are configured dynamically through a bootstrapping action. The line between bootstrapping and golden image. So items that do not change often or that introduce external dependencies will typically be a part of your golden image. For example, your web server software that would otherwise have to be downloaded by a third party repository each time you launch an instance is a good candidate. So items that change often or differ between your various environments can be set up dynamically through bootstrapping actions. For example, if you are deploying new versions of your applications frequently, creating a new AMI for each application version might be impractical. So you would also not want to hardcode the database hostname configuration to your AMI because that would be different between the test and production environments. Hence, user data or tags can be used to allow you to use more generic AMIs that can be modified at launch time. For example, if you run web servers for various small businesses, they can all use the same AMI and retrieve their content from an Amazon S3 bucket location you specify in the user data at launch. Now, AWS Elastic Beanstalk follows the hybrid model. It provides pre-configured runtime environments but allows you to run bootstrap actions and configure different environment variables to parameterize the environment differences. Now, the next thing is infrastructure as code. The application of the principles we have discussed does not have to be limited to the individual resource level. Since AWS assets are programmable, you can apply techniques, practices, and tools from software development to make your whole infrastructure reusable, maintainable, extensible, and testable. So, AWS CloudFormation templates give developers and system admins an easy way to create and manage a collection of related AWS resources and provision and update them in orderly and predictable fashion. You can describe the AWS resources and any associated dependencies or runtime parameters required to run your application. Your CloudFormation templates can live with your application in your version control repository, allowing architecture to be reused and production environments to be reliably cloned for testing. So this concludes